All right, here's a quick video to show how to calculate a couple of these problems from 9.10. So problem 1 says if 0.1 Faradays of electric charge pass through tin 2 nitrate solution, what mass of tin is plated out? So first, let's see that tin 2 nitrate is Sn because tin is Sn. The 2, or Roman numeral 2, means tin has a 2 plus charge. Nitrate, you just need to have memorized, has a 1 minus charge. So therefore, tin 2 nitrate is SnNO3 with a 2 on the outside of the parentheses. In the half reaction, tin 2 plus is going to gain 2 electrons and then plate onto the electrode tin, solid tin. So solid tin is going to be plated onto the solid tin electrode. So 0.1 Faradays of electric charge means you have 0.1 moles of electrons are being pushed through this system or going through the system. Because of the chemical reaction, for every 2 moles of electron, we get 1 mole of tin. Here's our mole-to-mole ratio here. Every 1 mole of tin from the periodic table is 118.71 grams of tin. Multiply across the top, divide across the bottom, and we have 5.94 grams of tin is the mass of tin that is plated out. So problem 2, on passing 0.5 Faraday of electricity through aluminum chloride, the amount of aluminum metal deposited on the cathode is what? All right, so we have aluminum chloride is this, and that's just because we know that aluminum makes a 3 plus charge, chlorine always makes a -1 charge. At the cathode, so one thing you can remember is there is something called red cat and ox. This is just a mnemonic to help you remember that the reduction happens at the cathode and then oxidation happens at the anode. So red cat and ox. So the reduction, which is gain of electrons, the aluminum 3 plus ions are going to gain 3 electrons and turn into aluminum solid. 0.5 Faraday of electricity means we have 0.5 moles of electrons are being passed through the cell. For every 3 moles of electrons, we have 1 mole of aluminum. That's just this coefficient ratio, 3 to 1. For every 1 mole of aluminum, we have the molar mass of aluminum, which is 26.98 grams of aluminum. Then when you multiply across the top, divide across the bottom, we have 4.50 grams of aluminum is plated onto the cathode. All right, go ahead and pause and see if you can do problem 3 before I work it out. Magnesium bromide is MgBr2. We just know that because of the charges that magnesium and bromine always make. They don't make variable charges. They only ever make the +2 and the -1. So the half reaction looks like this. 3 Faradays of electricity means we have 3 moles of electrons being passed through the cell. For every 2 moles of electrons, we have 1 mole of magnesium. For every 1 mole of magnesium, we have 24.31 grams of magnesium. Calculate this, and we have 36.47, depending on how you went around that, grams of magnesium is plated onto the cathode.